Yeah, perfect. Do a duplicate, please.
It's already there in the extended.
Duplicate. Nice. Now I can see the same what you guys can see. Our duplicate is duplicate, right? External should be the same as the screen. Should be okay. So I mean, duplication should be giving an error. I mean, paying 20K. Yeah, we just close a few things again. You can do so many layers on this and really compare a lot of useful data. Okay, so here, so I think here. Let me zoom out a little bit, I guess. Okay. I think we're looking at, Nagla here, Nagla East. So basically what I've done here is, so I mentioned, right, we talked about that 30-meter data, which is available from the NASA with their latest sensing technology. And so here we're basically looking at Nagla East, yeah. And you have here EP quota, I think, and it's not very visible because it's showing some stuff. But basically, I mean, I'll show you some links where you can download this data from the NASA website for any place in the world, even any range in India. You can download it degree-wise, so you can do for every latitude, every longitude, you can get it. That's one possible, I mean, you can do it directly through the website. Should have taken my mouse. But you can also do it from the tool itself. So in this tool, actually, you have lots of online sources of data. I mean, we are mostly used to Google, but you have lots of data, topographic maps from commercial, non-profit organizations, I mean, freeware applications available. Of course, many of these are mostly for the United States, Europe. So if you go to like terrain data or topo maps, again, there are lots of data available. Remember what I told you here, SRTM is what is used, 3 seconds precision, so 90 meters is used from Google to make their Google Maps. But recently we have something which is better, the Aster GDEM, which is 1.5 they say, but normally it's supposed to be 1 second. So you can click on this and you can download it for certain areas, certain that you're interested, say Venti or Nagla, Palani, download this data. So once you have downloaded this data, this looks like this. I mean, of course, you're just looking at it in a certain visualization. So in this case, they just use a little bit of shading here, and the shading is actually, it seems related to the altitude in this case, I guess. So blue is like low, 0 meter, and then it goes up till some kind of 1,000 meter here. So green is in medium height, 500 meters, around 600 meters yellow. So it downloads this data. So this data is available, but as of such in the raw format, it's not useful. So first thing that we'll have to do with the satellite data is generate contour lines from this. So say for example, you can do a lot of interesting analysis here. One of the things you can do is to generate contours. So you can generate contours, and unlike Google where you have fixed contour lines, every 20 meter you have a contour line and every 100 meter you have that pick line, remember? Here you can do whatever you want. Here you can do something like, I can do it say every 10 meters, double the precision as Google. So one minor line, minor contour every 10 meters, and then every 10 times 10, so every 100 meter I'm putting a pick line. And I can add a little bit of shading also. All the rest we take default option. So if you do this, so basically it processes this raw data and it generates something that you're familiar with, which is the contour lines. So if you now say, for example, we zoom in a little bit, say here on the picnic pool, if some of you guys have gone to that, if you look at this resolution, actually, I mean, this is 3 times the precision that you normally get through your Google terrain data. And picnic pool, famous, I mean, campsite, which you see is here. You'll have a stream above the picnic pool, you have some 50 meters fall here, which is clearly visible, almost like 100 meter drop. Here you have the gorge where we normally ferry people through. And then here the stream proceeds uphill. right? So you can generate contour lines. What else you can do is, I mean, this program is like there's a lot of mathematics behind this. What you can do is you can also find the ridge lines. So this can actually show you, you can add certain thresholds in this, like in small ridges or only at a certain gradient. There are a lot of options are there. So at this specific setting of 200, you can draw certain ridges here. So it's basically showing you, right, ridges like basically, right, you can walk on the ridge here to this peak and follow this ridge down to this place. Right, and so it shows you different ridges in the place to go, to cross actually, to go from lower to higher altitudes. Another thing you can do is, it's pretty cool, it can also generate watersheds. So this is something that I found just a few days ago. So watershed means it basically does an analysis. What it does is it basically checks if the rain falls on this place, how is the rain drained from this place, right? So remember what I told you, anything that falls on the right side of the ridge will go to one valley, anything that goes to the left side of the ridge, right? The ridge being the highest point, being what they call a water divide, the British in their topo terminology. Anything on the left, on the other side of the ridge goes to another valley. So you can generate a watershed here. And basically what it's going to do now is it's going to take a look at the whole of Nagalapuram. Yeah, all the data, okay. And it's going to basically analyze if there is rainfall on this range, how is the rain gonna, how is the water going to be drained, where are the streams, and which places they are drained to which streams. So very useful, right? Because now we have a good idea. This stream is draining like a large area or a small area. So you have a good idea basically. So let me just zoom out a little bit. Just a second, I think I have to hide a few things because it's showing. You should actually show some proper colors here. Pen video. Sorry, this is a little bit of a wrong setting. I think we have taken it too big. So let me just do another watershed analysis with a different threshold. So I think this 5,000 is a little bit, let's make it 1,000. So what we're seeing, we should get some pretty decent idea now how the whole of Nara is being drained. If everything goes well. So it needs to do a little bit of mathematical calculation, right? Depending on the ridges for that. So here basically you already get some idea. So all these areas in different colors here that you can see. Say for example here, this place which is shown in the same color. Like here this whole place actually, this actually is drained into this side of the stream. So here you can see this whole yellow thing, this whole yellow area is going to be drained towards here on top of the picnic pool actually. It's basically looking at all the ridges. As you can see here you have ridge, anything on the left side of the ridge goes into the picnic pool, anything on the right side of the ridge goes somewhere downstream. So you kind of get a very good idea overall, like for the whole of Nagala here. It's a little dark because of all these topo lines, so you need to play around with the setting, but over the whole range, like say even here on the central peak and some mid-east, you can see all the water in this orange color will be kind of going to the same place. It's also showing the blue lines basically, which is your water streams. Which is very cool in the sense that just downloading that topographic data, that really have data from the satellite, analyzing that, it's able to understand how the streams are flowing through this terrain and how basically water is being drained. So it's pretty cool. I mean, but you need to play around with this yourself. You need to tune the parameters a little bit. It's, I think, very helpful in understanding like how much area is being drained by a certain stream to kind of predict the probability that there's going to be water in a given stream at a certain season during the year. And then one last thing that maybe I want to show, maybe not super useful for trekkers, but kind of interesting is this option. This is already more advanced, I think, and more for other applications, but just to show you the power of the tool. let's go a little bit down. So let's get rid of these layers, because if you put too much on top, it becomes confusing. And so one thing you can now do is the following. You can do this one here, analysis. Yeah, you can actually look at this tool, which is the gear transmitter tool, view shed tool. So what is this view shed tool is? View shed tool is actually I can think of certain purposes which will be useful for tracking or rescue. So the view shed tool allows you to go to a position, say, for example here, somewhere here, right? I'm at this position, and from this position I can go like, say, 100 meters above the ground level, not the sea level, but say the ground level. And now the tool will calculate, say like 100 meters above this exact position, what are all the places in this mountain range that are visible to you, right? Which is useful, because that can be interesting if you say have like a ham radio, or you need to get a clear view to somebody, right? The tool is going to calculate from that, say, tower or that peak or somebody standing there, whether that or transmission tower, whether there is a clear view in which places will have a clear view to that specific point. So that's a little bit of a three-dimensional analysis, which takes a little bit more time. And that's pretty complex, because it has to calculate, right, like which places will be hidden by peaks in front of those places, and all that kind of visibility analysis. So basically you get a very weird picture, but what you're going to see is that all the areas which have a clear view to that point, in that point 100 meters above that point, actually above the ground, which parts of Nala are visible from there. So that could be, I guess, useful, like even if you need to get rescue, right, with a cell phone, you need to get a visibility to a cell phone tower somewhere, you can calculate which place in Nala you will have to go. So it's given this now, but again, it's putting layers on top of layers, so that we just hide maybe the contour lines so that you can see the other things. But here you can see the kind of the visibility analysis. So all this red color actually is basically what is visible from this point, 100 meters above this point. All this kind of is visible. So here you can see some places which are not visible. These are basically places which will be behind ridges, behind peaks. Either you're hidden behind a peak or a range, or you're somewhere deep in a valley, so you don't again have a visibility. So, I mean, just to show you that this global mapper is amazing. Once you download some freely available satellite data, you can do so many analyses. You can generate contour lines, you can automatically find ridges, you can automatically detect streams, you can automatically see how the water drains, right? You can generate that area to get a clear view, say, to the village, to call for help or to send some Morse code with your LED torch in the middle of the night for rescue. I mean, it's a little bit more advanced. I guess they have some other purposes, like some, for cell towers purpose and other transmission kind of applications. But for tracking, there can also be some useful applications. Okay, so that's all what I wanted to show. Are there any further questions before we close? Before you guys get too sleepy or too hungry? Okay, I mean, this is again all theory. Only when you go in the field, right, 5, 10, 15, 20 tracks, you will get more and more experience. You'll get a better feeling of GPS, you'll get a better feeling of these maps. It's only practice, just like anything. This stuff also needs a little bit of field practice. So, anyone interested, just play around with these tools, manipulate some stuff. If you're serious about tracking, I think everyone's serious about tracking should get a GPS. So you can start downloading maps, you can go to the wild and kind of get familiar with navigation movements. But at the same time, be careful, right? Let's say, the wilderness can be beautiful, but can also be merciless. So initially at least go with some experienced group or experienced people so that you're safe. Okay then, no more questions, anyone?
Can we generate an elevation map for a specific part?
No, very interesting, I forgot that. I mean, more interesting application would be, so say for example, I wanna, that's a very good question. And so that you can do with a GPS log after you go there, but can you do that in drones? Yeah, you can actually do that. That's a nice thing, right? So say I'm planning a small trail, right? The part of the difficulty of the trail is the ups and the downs. So can you generate an elevation trail for a certain path? You can do that here because the satellite data contains elevation. This new Lenovo flashback is like a total disaster. So it's really nice, you can keep adding layers, you can combine layers, you can put transparency in multiple layers. So let's go back to our contour lines a little bit and let's do a small trail. Oh, okay. Okay, today we want to go from Nagla east to west. People participating in the treasure hunt have to do this step. So say for example, I think this is the one here, this tool. So basically I'm going to draw a path here. I'm starting at the east, right? So maybe let me first go a little flat here. Let me get on this ridge, right? Not too steep. Get on the ridge, go to the peak. Here it's all a bit steep, I don't have a choice, so okay, maybe I can just go there a little, then I can go here on this ridge. It's going to be quite steep, but anyway. Yeah, boom, get on this peak. And then maybe, let me just go down here to some stream, set up a campsite, voila. So if I click now, voila, you're going to get your elevation profile. So you get a good idea, right? And it's like fully mathematical, right? Any point, it will show you the exact location at any point along this line. It shows you the distance and everything. So it's pretty cool. Like for example, I mean, you can do stuff like, you can open these, once you georeference a map, say like that Soviet army map, which contains a lot of interesting stuff like old forts and stuff. This is all NASA data download. So for example, this is a Soviet army map of Nara. Like this. So let me go a little bit north. So you can see, right, the scale I told you is 1 by 200,000, so 1 centimeter on my map is 2 kilometers. You can see that it's pretty ugly a little bit as I'm zoomed in, and as the resolution is not that good. Let me zoom out a little bit. So here we have here, for example, you can see that here somewhere on the top of Tada. Remember, we already, so here somewhere at the Tada Plateau, you have the Tada waterfalls on this elevation. But here you have the fort. Remember, that's what I showed you, those pictures that we had discovered that fort along the ridge, looking over the Tada Valley using this position of this marker. Here you have a jeep trail which we have explored in some CTC treks. The jeep trail goes to one of the highest peaks of the Tada Plateau, 730 meters, which kind of allows, I guess, the military to overlook for incoming ships. So we have some old forests, again, house here which was built. We have found the ruins of this place. And then on the other side again, I showed you some religious statue, 3 meter high, carved, that was actually in this place. So we're only able to find these places because of analyzing these ancient maps. I mean, not ancient, but 80 to 100 years old sometimes. So again, with this tool, you can identify the position, right? You put the hand here, right? And if you look now in the bottom corner, you know exactly in this place is at 30 degrees, 34 minutes, 9 seconds north, and then east to 79, and you can see the rest of the screen. So you can really pick out jeep trails, lines, streams, peaks, villages like forts, bungalows, anything you can pick from these maps. And you can get the latitude, longitude, you can store them in a GPX file, remember, you can download it in your GPS, and then as you go in the field, you will have contour lines, but you can also have these reference points in your GPS to allow you to discover these ancient human, ruins, basically. So see, I mean, that's what I mean with you need to have your maps properly georeferenced so you can load them in a tool and you can start looking at it and knowing which places. You can put trails on top of this, you can generate contour data, look at streams, and you can basically study. There's always a bit of study involved before the trek to plan an interesting trail with a couple of interesting discoveries if you want to have a nice trek. If you just go without preparation, you're quickly going to get stuck here or there.
Any questions? Otherwise, I think we'll wrap it up here. Any more questions at all? People are very silent. Was it useful, whatever was given today? Yeah, it's nice, but again, use it wise, guys. Don't be too confident or too excited, so be a little careful. You're in the wild there's nobody there. There could be a bee nest hanging on top of you. There could be a deep pool which surprises you. Always be careful when you go into the wild. Don't go alone, don't go with two, don't go with three people, go with a sizable group with experienced people, navigators, experienced swimmers, so that you have some safety nearby. Nobody else can help you there. Okay then, thank you for your attention. Hope to see you on some track sometime. Okay, thanks.